Okay, so here's a little review on how to do dimensional analysis, our lovely Wunderfractions, yeah. Remember, if these are too easy for you, feel free to skip ahead to further problems. I believe I got 4 examples, and then there's one at the very end, so that you can practice on your own. So here we go, example number 1. How many centimeters are in 2.6 meters? So how do we deal with these? We attack with these by trying to figure out, first of all, what do we know? So again, remember what we know goes in the top left corner as we are writing. So I'm going to start right here, 2.6 meters. I'm going to draw my nice horizontal line here. Now, what am I going to convert it to? Well, I need to convert from meters to centimeters. So, do I have a conversion between meters and centimeters? Of course I do. As you should hopefully remember that, there's a real simple one, 100 centimeters equals 1 meter. And so that's the conversion that we can use here. We're going to enter it in directly as we would write it. Again, making sure that when we're doing this, our units are canceling each other out. So if we've got a unit like meters here, that means that the meters has to go down into the next step right here. So as I write this, I'm going to write meters down here. I'm going to convert it to centimeters. Again, why am I doing that? Because that's the conversion that I have down here that I can use. So I'm going to write my numbers in. 1 meter is 100 centimeters. I never leave myself enough room when I'm doing this, and it's okay. So, do I have the units that I want? Well, first thing we got to check to make sure our units cancel out. Meters cancel out with meters down here. The remaining units we have is centimeters, which is what we're looking for. So we are done. We can do our calculation step at this point. So, calculations. Multiply across the top. 2.6 times 100. And then on the bottom we just have a 1, so that makes it really, really easy. So our answer, of course, is 260 centimeters. Last thing we got to check is sig figs. Do we have enough sig figs or our correct sig figs in here? Again, our original number that we had is 2.6. Therefore, our answer needs to have 2 sig figs. And if we take a look at this right now, it actually does have 2 sig figs to it. That final one is not significant. So there we take a look at it. 260. Believe it or not, has 2 sig figs. I know that's always a weird one for students, but there's our correct answer written with a proper number of sig figs. Example number 2 should go a little quicker here. How many feet are in 325 centimeters? For this one, we need a little bit of a different conversion. And again, with funky little weird English metric conversions, I'll give you any of those. In this particular case, the weird conversion that we would need, 2.54 centimeters equals 1 inch. So again, I'll give you those so you've got it, but we'll attack this otherwise the same way. So here we started off with what we know. What do we know? This is where we're starting right here, 325. So 325 centimeters. Draw a nice little horizontal line. What's next? Well, we want to be able to convert from centimeters to feet. But I don't know centimeters to feet, so I can't really do that one. I do have centimeters to inches, however, because that's the one that I gave you way up there. So let's include that one in our next step, because after this step we can convert from inches to feet. So again, centimeters are on the top here, so they have to be in the bottom in the next step. So centimeters goes here. We'll convert to inches at the top. Again, we're going to use this conversion that's up here at the top so that we can get that into our wonder fraction. So enter it just exactly as you'd say. This is 1 inch is 2.54 centimeters. Okay, we're not quite done yet. We got to keep going a little bit because again, we're at inches now. We don't need to be in inches. I mean, it's good to be in inches. Centimeters are gone, but we're in inches. We need to get somehow to feet because our answer up there is in feet. So let's take a look at our next step. Again, if inches is up here, they have to go down in the next step. So inches will be here, and now we can convert it to feet. I think you should all probably remember that 1 foot is 12 inches. Are we ready to go? Yes. We've got inches are now canceled out. Our units that we have left is feet. That's what we want to have. So let's do our math. So multiply across the top, divide by the bottom. 325 times 1 times 1. On the bottom, 2.54 times 12. By the time you enter all of this craziness into the calculator, you get an answer of 10.6627, and then there's a bunch more that comes up to it. So how do we round this? We've got to take a look at our original. How many sig figs do we have? Sig figs, again, comes from our original values. Our original number right here is 325, so we need to have 3 sig figs. Okay, so take a look at our number. There they are. There's our 3 sig figs. But now we got to round it. Take a look. Stop truncating your numbers. This number after here, the 6, means that we actually have to round this number up just a little bit. So our final answer is actually 10.7, and our units is feet. 10.7 feet for our final answer in 3 sig figs. Next one. How many grams are in 1.78 moles of sodium chloride? Whenever we're dealing with moles of chemicals, you know that you're going to need to use a chemical formula, and you're going to need to eventually use its molar mass. So remember how we do that? We figure out what the mass of sodium is from the periodic table, the mass of chlorine is from the periodic table, and we use those together. So grab out your handy-dandy periodic table. I know you've got one right next to you, because I know I do all the time. But on your handy-dandy periodic table, you will see that sodium weighs 22.99. Chlorine weighs 35.45. So we know that those two together have a combined mass of 58.44. This is our grams per mole of sodium chloride, NaCl. So that's the conversion that we're going to be having to use in this problem. All right, ready? Start with what we know. 1.78 moles NaCl. Draw a nice line. What are we converting it to? Well, again, we are converting moles on the top. So moles has to go on the bottom, moles down here, and then we're going to be able to use grams. That's what this thing is used for. It's going to get put in this step right here. So 58.44 grams of sodium chloride is the same as 1 mole of sodium chloride. And now it's pretty simple to see the math on this one. 1.78 times 58.44 divided by 1. Our answer here, 104.0232 something or other. Again, we have to look at sig figs. How many sig figs are in this problem? Our original problem has 3 sig figs. So we have to answer put our final answer here in 3 sig figs. So here's our first 3 digits. Again, we take a look at that next number there to figure out if we round up or round down. A 0, obviously, we round it down. So our final answer here is going to be 104 grams of sodium chloride. Next one. How many moles of copper 2 nitrate are there in 25 grams? So in this one, first thing you got to do is be able to write your formula correctly. Oh man, you better study that stuff. Copper 2, copper with a 2 plus charge. Nitrate, NO3, has a 1 minus charge. Now there's going to be a little 2 down there. So calculating your grams per mole, your molar mass of this is going to be a little bit more challenging. So when we do this, we find out that copper is 63.55, and there's 1 of them. Nitrogen, 14.01. But now there are 2 of them. Why? Because there's a 2 in that formula. Oxygen is 15.99 grams times 3 of them times 2 of them. Why? Because there's a 3 and then there's a 2. That means there's actually a total of 6 oxygens that are present there. When you get your handy-dandy calculator out and you do all the math on this, you'll find out that the full molar mass, 187.51 grams per mole. Again, if you're not sure, please go back and hit pause or ask me a question during class and I can get you to work on that. But you've got to be able to do this part right. So now it's pretty straightforward. It's just a little wonder fraction, 25.0 grams. It's supposed to be a point, sorry. We know that 187.51 grams is 1 mole, 4CuNO3, 2, copper 2 nitrate. So now, what do we got to do? Well, we're looking for moles. Our final answer is in moles, so all we have to do is multiply, divide. 25 times 1 goes on the top, divided by 187.51. Not going to be a very big answer. By the time you do this, you get a number like 0.13326, and a bunch more after that. Sig figs. What do we got to do for sig figs on this one? Our original value has 3 sig figs, 25.0. Therefore, we have to have 3 sig figs at our bottom. Again, we take a look at this number to determine how we round. Our final answer is going to be 0.133 moles. There's our final answer for that one. Okay, last one. Here you go. So, take a moment, see if you can do this one on your own. Take a second to read this, then hit pause, solve it on a piece of scratch paper, get your calculator out, and then resume play. You'll be able to check what your answer is. So hopefully this will work out well for you. But the question is, a sample of sodium sulfate has a mass of 125 grams. How many moles does this represent? Hit pause now. Okay, welcome back. So, let's solve this out. Sodium sulfate, we've got to start with this part and figure out what our formula is. Sodium sulfate, there's sodium, it's a 1 plus. Sulfate is a 2 minus. So you need to have a 2 down there in your formula. So when we take a look at finding our molar mass, sodium, 22.99 times 2 because there's 2 atoms present. Sulfur is 32.07. There's only one of those. Oxygen, 15.99, and there are 4 of those present. So by the time we add all of these lovelies together, we get 142.01 grams per mole. So now it's a pretty simple matter of doing our little conversion. Get back to black pen. I don't know, red bothers me. So 125 grams. We know that our molar mass conversion is 142 grams of this compound equals 1 mole. Sorry, there's an extra little line in there. When we do this division problem out, we get 125 times 1 divided by 142. And our final answer is 0.8802 something or other. Putting it into sig figs, we should have 3 sig figs in our problem because we've got 3 sig figs in the number 125. So we take a look at this. Here's our 3 sig figs right there. That number right there says round it down, so our final answer is 0.880, and our look at units is moles of Na2SO4. Hope you did all right on this. If not, give me some answers or some questions tomorrow, and we'll take a look at how to solve it. Thanks. Have a good night.